It's interesting, this idea of the Big Bang creating the universe. That's what Einstein's theory says. That's textbook cosmology if you like. But the current textbook picture suggests that there was a phase in the universe's life before the Big Bang. If you define the Big Bang as the hot, dense phase from which the universe appeared to burst 13.8 billion years ago, then that phase is called inflation. What we think happened is that before the Big Bang, the universe was accelerating exponentially fast. This means it was doubling and doubling and doubling in size at an extraordinary rate. The numbers involved are almost beyond comprehension. We think that if you started with a universe smaller than a single atom, it would have expanded to a size far larger than the whole observable universe, which contains about 350 billion galaxies, in less than a millionth of a second. This was a very rapid and exponentially fast expansion. When that expansion stopped, all the energy driving it was dumped into space, heating it up and producing the particles of matter from which we are made, as well as all the things we see in the sky. That is what we observe as the Big Bang. While this may sound fanciful, it is actually standard cosmology at the moment. The big question then becomes, what started the inflation? What stopped the inflation? How long did the inflation last? The answer to these questions remains uncertain. We don't know. Initially, there was an infinitely dense, tiny ball of matter that began to expand, eventually giving rise to the atoms, molecules, stars, and galaxies we see today. But what was there before the Big Bang? What was the state of the universe before it? The universe underwent a breathtaking cosmic expansion, doubling in size at least 80 times in a fraction of a second. This rapid inflation was fueled by a mysterious form of energy that permeated empty space itself, leaving the universe desolate and cold. Only after this phase did the hot, dense conditions of the Big Bang emerge. Some theories suggest that inflation does not stop all at once. It stops in patches. Every time it stops, a new universe forms. According to eternal inflation theories, there may not be just our universe, the part we can see, but potentially many universes, perhaps even an infinite number of them, continuously being produced. What should we make of this? This is where modern cosmology currently stands. If cosmic inflation correctly describes what happened before the Big Bang, it may push the ultimate answer to our origins beyond the reach of science. But that only shifts the question further back, because we still don't know what came before inflation. It is doubtful that we ever will. There are theories suggesting, as I mentioned, that there may be more than one universe, potentially an infinite number. It's a mind-boggling idea, isn't it? Now I should mention one more thing. If this is true, then some theories propose that what we call the constants of nature, things like the strength of gravity, the speed of light, and the masses of particles, can vary from universe to universe. This leads to a profound question. Why is our universe so perfectly suited for life? Why do stars produce carbon and oxygen, the essential elements for life? Why is everything so finely balanced to allow living things to exist? The answer, according to these theories, is that every possible combination of natural laws exists across different universes. We obviously find ourselves in a universe that allows us to exist because, well, if it didn't, we wouldn't be here to ask the question. So, how likely is it that such a universe exists? If there are an infinite number of universes, then it is inevitable that some will have the right conditions for life. I must stress that this is highly speculative. However, the first thing I mentioned about inflation, the idea that there was an exponentially fast expansion before the Big Bang, is not speculative. That is mainstream cosmology. The idea that inflation might lead to multiple universes is more speculative, but still scientifically valid, and there are researchers actively exploring this concept. Inflation tells us that the period before the Big Bang was extremely cold and empty, except for the energy carried by space itself. This energy stretched the universe to an enormous size, setting up the initial conditions that led to the Big Bang. However, there are alternative theories to cosmological inflation that attempt to explain what caused these initial conditions. One such theory suggests that the universe may have extra dimensions. Imagine we are living on a sheet of paper. There could be another universe, also existing on a separate sheet, floating nearby. Some theories propose that when these sheets, or branes as they are called, collide, they heat up and create what looks like a Big Bang on each sheet. In this view, the Big Bang might have been caused by two branes colliding and then separating. This is another possible explanation for what happened before the Big Bang. These theories, branes colliding, the multiverse, may seem extremely speculative and detached from reality, but they are backed by mathematical reasoning. Furthermore, theories about the early universe do have experimental support. One of the most exciting aspects of cosmology is that we are now making direct measurements to test these ideas. The experimental foundation for these theories comes from something called the Cosmic Microwave Background Radiation (CMB). This is the oldest light in the universe, released about 380,000 years after the Big Bang, when the universe had cooled enough for atoms to form. At that point, the universe became transparent, allowing this ancient light to travel freely through space. Today we have a satellite called Planck, a European mission, taking highly detailed pictures of this light. The CMB acts like a baby picture of the universe, much like an ultrasound scan of a developing baby. By analyzing the structures and properties in this light, scientists can gather clues about what happened at the very beginning of time. These measurements provide critical experimental support for our theories of cosmic inflation. The twin pillars of modern physics are Einstein's general relativity and quantum theory. To fully understand how the Big Bang emerged, and what came before it, we need a theory that unifies these two frameworks. Only with such a theory can we answer the deepest questions in cosmology. What is space? What is time? What is the universe? Where did it come from? The most distant objects in the universe are about 47 billion light-years away, making the observable universe about 94 billion light-years across. If you're wondering how the observable universe can be larger than the time it takes for light to travel over the universe's age, the answer lies in cosmic expansion. The universe has been expanding throughout its history, meaning that very distant objects are now much farther away than their original light travel time suggests. Most scientists believe the universe extends far beyond what we can observe. But is there anything beyond the entirety of the universe? Probably not. There is strong evidence that the universe may be infinite in extent. If we take what we can see, the observable universe, it certainly extends far beyond our field of view. Why do we think this? Because measurements of the universe's curvature and structure suggest that it continues well beyond the tiny bubble we can observe. Just how far it extends is unknown, but it could very well be infinite. Considering the latest discoveries and measurements in physics, we have attempted to answer some of the biggest questions. What was there before the Big Bang? How big is our observable universe? What lies beyond what we can see? But are we forgetting something? An important question naturally arises when we contemplate the beginning of everything. How will the universe end? The current best estimate is that the universe will continue expanding forever.